Have you ever think of how the GPS works in determining the positions of two objects? Or how the surveyors measure the area of land using a boundary mark? Or how can anyone measure long distances between two structures? What's the math behind it? It's triangulation! Triangulation is a technique used in navigation to determine the positions of ships or aircrafts. It is also used in engineering to determine the directions of roads or any under construction structures. Triangulation is based in geometry, which states that if one side and the two angles of a triangle are known, the other two sides and the remaining angle can be calculated easily. This technique and our knowledge in trigonometry will help us obtain values for distances and angles that seem to be immeasurable.
Consider this situation. Smart telecommunication tower was proposed to be built along a straight highway in an east-west line 6 kilometers away from Globe Tower. From a broadcasting company building located north, the line of sight of Globe Tower is 30 degrees south of west, while that of the proposed smart tower is 50 degrees east of south. Which among the two towers is nearest to the broadcasting company building?
This situation will give us this illustration. You have observed that we are forming here an oblique triangle. A triangle having no 90-degree angle. With our basic knowledge of triangles, we can simply identify which among the two towers is the nearest. Remember that the side opposite the lowest degree angle is the shortest. So, comparing AB and BC, BC is shorter than AB. Thus, Smart Tower is nearest to the building. But, what if we want to know the exact distances of the towers to the building? Law of sine can help us solve the problem. This law is used in solving problems involving oblique triangles. Law of sine can be determined by this relation. This means that the ratio of the sine of angle to its opposite side is proportional to the ratio of the other sine of angles to its opposite sides of a given triangle. We will find first the distance between the building and the proposed smart tower. Based on the illustration, we will use this equation. Substituting the values to the equation, we have applying cross multiplication, computing the values of sine 30 degrees and sine 110 degrees. Using the scientific calculator, we can substitute the following values. Dividing both sides of the equation by 0.9397, so A is equal to 3.19. Therefore, proposed smart tower is 3.19 kilometers away from the broadcasting company building. How about the Globe Tower? Now, it's your turn to do the rest of the problem. We are facing with different problems every day. It seems that others are impossible to solve. But with proper knowledge, we can make it possible.